Okay, now we're going to talk about ionic formulas and how to write ionic formulas. We should also know what molecular formulas look like, but none of our questions were on molecular formulas with prefixes, and ionic formulas are much more common on the Regents exam, for instance. So this is the absolute bare bones basics of what we need for our notes for ionic formulas. We need to cross the charges so that the total positive and negative charges cancel out. Now, if the charges already cancel out, that means you just need one of each ion. So you just write the formula with one of each ion. But if they don't already cancel out, you're going to cross the charges. You're going to cross the numbers down, not the little plus and minus signs. Sometimes there's a Roman numeral in the name. There's a Roman numeral in the name. If it's there, it tells you that the charge on the metal is that charge, that actual number, if that metal has multiple oxidation states. So let's quick remember our Roman numerals. We don't need all of them. We really just need up through 7 is really all we need. So if there's an I, that's a +1. There's a 2 for a +2, 3, and then 4 would be IV. 4 would be 1 less than 5. 5 is a capital V. As I've said before, it may or may not look like that. It might just be a V. And then as you go more than 5, you go VI for 6, VII for 7. That's about as crazy as it's going to get for charges on metals, a +7. These are the actual charges. They do not mean the first out of all the charges listed or the second out of all the charges listed. They literally mean +1, +2, +3, and so on. Okay, now, here is where a lot of us tripped up. Reduce the numbers if necessary. All ionic formulas are empirical formulas. By definition, all ionic formulas are simplest reduced ratios. So this also brings in the definition of empirical formulas. Okay, so let's address that here as well. Simplified. Simplified, reduced. You look at those subscripts, you look at the ratios, you see if the ratio can be reduced. In an ionic compound, you're looking at the ratio of ions. Can you reduce the ratio of ions? Sorry about that bell. Since we're talking about formulas, I'm also going to bring in one last little thing that doesn't really belong in other categories, which is what are the formulas for the diatomic elements? First of all, notice we're talking about elements. This has nothing to do with compounds. So CO2, nothing to do with that. Anytime you have more than one element, nothing to do with this. Diatomic, 2 atoms of the same element bonded in a molecule. And so, of course, in order to memorize this, which elements are diatomic, we remember Mr. Brinkelhoff. When you get to this part of it, it's not a K, it's a Cl. Brinkelhoff. And one reason it's chlorine instead of a K is because K is a metal, and all of these guys are nonmetals. I can tell that because these are molecules. So nonmetals form molecules. So these 7 elements are the elements that when they are alone, when they're pure, they happen to be diatomic. Okay, now let's go to the questions in the test that have to do with this. We'll start with this one, and then we'll go back and look at other formulas. Okay, which elements are diatomic? Question 22 said, identify one diatomic element found in the atmosphere. There's more than one right answer, but it's got to be one of these 7. So it's either bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine. The ones that they mention that you could choose from are, let's see, nitrogen is an option, oxygen, hydrogen, and that's it. Nitrogen, oxygen, or hydrogen. So you could say nitrogen, oxygen, or hydrogen. You could say any one of them, or you could have written the formulas N2, O2, or H2. You don't have to write all 3. Any one of those is a right answer. Everything else there is a distraction. Argon, carbon dioxide, methane, ozone, especially if you don't know what the compound is. It's just a distraction. So just ignore it. Some people chose some of these, like carbon dioxide, maybe distracted by the fact that dioxide had 2 oxygens in it. So you're thinking, oh, diatomic, 2 oxygens. But it's got to be an element, a pure element. And carbon dioxide is a compound. Okay, let's look at some formulas. First of all, let's just remember that thing about empirical formulas. Empirical formulas are simplified and so on. So number 9 on test B says which type of formula represents the simplest whole number ratio. That's got to be empirical formula. This guy is number 14 on test A. Here's another one about empirical formulas. It says which formula is an empirical formula. So it's got to be something that's simplified or something that cannot be simplified. So if your subscripts have a common factor, then that thing is not empirical because it can be simplified. So the only one here that works is the last one, because it's CH4, which is of course a 1-to-4 ratio, and that can't be simplified any farther. 4 to 10 can be simplified because they're both even. You can divide them both by 2. 3 to 6 can be simplified. 2 to 6 can be simplified, but CH4 is as simple as it gets. This is question 2 on version B. And it's question 7 on version A. Okay, now let's look at some actual ionic compounds. For instance, number 3 on version A, which is also question 15 on version B, says lead 4 oxide. IV is 4, it's the charge on the lead. So we're going to follow our directions. We're going to notice that positive 4 is the charge on the lead. We have to look up the charge on the oxygen. If you don't look up the charge on the oxygen, you only have half the information. And then we're going to cross the charges, and then don't forget that important last step, reduce them. This one will involve reducing. Now you can look up lead on the periodic table and look up its charge, but you already know its charge because it had the Roman numeral IV, 4. It had as choices either +2 or +4, so we're going to use 4. Look up oxygen, -2. If these charges canceled out already, I would just write PBO, but they don't. I need to cross these numbers down. By crossing these numbers down, I will make the positive and negative charges cancel out. I bring down the 2, and I bring down the 4. They become the subscripts. Pb2O4 is not the answer. It's not even a choice. Because what can you do with a 2-to-4 ratio? You can simplify it to a 1-to-2 ratio. This simplifies to PbO2. Okay? All ionic formulas are empirical formulas because ionic compounds are large crystals that just repeat and repeat and repeat, and there's no reality to the numbers. The numbers only tell you the simplest ratio in which those 2 ions bond. These bond in a 1-to-2 ratio. There's no reason to say they bond in a 2-to-4 ratio. So that is the first one.
Brad Blakeman, please come to the main office. Brad Blakeman.
Let's look at 16 in version A. It's also 11 in version B. Zinc carbonate. Again, we're going to look up both charges. And then 17 right after it, copper 1 sulfide. Again, we're just going to look up both charges and cross them. This also happens to be number 13 in version B. Okay. Here we go, zinc carbonate. On the periodic table, I look up zinc. I have to look up its charge. It doesn't have a Roman numeral, so I don't know its charge until I look it up. There he is, +2. Now, carbonate isn't just carbon. If it were just carbon, it would end with IDE. It would be carbide. Carbonate must be one of my larger polyatomic ions. So I look for him here. Carbonate, CO3 with a 2- charge. Now, this is one of those nice cases where you don't have to cross his numbers down because you can tell right away that the +2 and the -2 cancel out. If I were being really lazy, I would just scribble them away. And if I were being slightly less lazy, I would rewrite it nice and clean. ZnCO3 is zinc carbonate. Okay. The next question asked for copper 1 sulfide. I can see here that copper can be +1 or +2. I don't even really have to look it up because they told me with the Roman numeral that I want copper 1. And sulfide has that IDE ending, so it must just be sulfur. Here's sulfur, -2. Okay. The +1 and the -2 do not cancel each other out conveniently, so I need to cross the numbers down. The 2 ends up there. The 1 ends up here, but as I've said many times, we never write the 1. So Cu2S. Okay. Now they love questions like this because they want you to read the name copper 1 sulfide, and they want you to think that that 1 is in the formula somewhere right after the copper, and it's not. It's the charge on the copper. It's really just telling you the variety of copper. You know, copper, this version, bonded to sulfide, see what happens. So when you cross it, there you go. Okay, I believe those are all of our formulas that we need to fix in the test. Hopefully you found the places in the test. And let's tackle a straightforward one for our problem to do on our own. So you're going to write the formula for this ionic compound. Chromium Vi chloride.